Now, what are the quality characteristics? We can say that the elements that define the intended level of quality of the product or service is a quality characteristic. So you can categorize. There are two types of quality characteristics. Largely, you can say is attributes and the variables. I'll write it. Attributes and variables. So attributes and variables. What do we mean by attribute and what do we mean by variable? Let's say we talk about amount of quantity in 1 liter pack of milk. Okay, so if it is exactly 1 liter, then it is a good quality. You can say that the with respect to the quantity, the quality is good. And in another case, we talk about surface finish, like smoothness of your mobile screen. So it is sort of an immeasurable thing. Although smoothness could be measured in Brinell hardness number, but still largely for a non-technical person, it is sort of a immeasurable entity, smoothness. Okay, so we can say the variables are measurable and the attributes are we can say it is confirming or not confirming, and or that can't be measured can't be measured. Now, can you give examples like more examples for variables? Anyone? If you look around you, everything has a quality. Okay, like glass, we say we have a glass in our hand. So we can define that. How do I define a good quality glass? Let's say we're talking about your glass, right? So how do we say density, okay, and the clarity, the transparency which is there in that? These could be the things. Or what are the quality characteristics of a mobile phone? Connectivity, uh, and
Battery life.
yeah,
Battery life.
battery life. Okay, so and many things could be there. You can count 50 if we go into technicalities. Also, you can give 50 quality characteristics. Now, many of these quality characteristics are measurable. Many of these quality characteristics are not measurable. Now, if I say uh, for a car, okay, so we can say for a car, acceleration and braking characteristics, like in how much time does it accelerate within generally the parameter for acceleration is like in how much time does it reach the 60 km per hour speed. Okay, so here the quality characteristic with respect to the functionality, or how was the ride of the car? Was it comfortable? Did you feel cozy enough in that car? So that is again an attribute. Okay. Uh, if we talk about airline journey, so we can how can you have one parameter for airline journey? Can you tell? Give me one parameter.
Travel time.
Travel time, exactly. Uh, uh, in fact, does it comply to the timetable or not? A number of journeys which actually arrived at the destination on time. Okay, that's a variable. And the attribute could be, was the food acceptable or not, or the quality of the food, you can say, is uh, attribute. Okay, similarly, for car, you can say what will be a variable character, another variable characteristic with respect to appearance. It could be number of blemishes which are visible on a car. Blemishes means scratches and all. Or attribute could be, is the car as per the specific, is the color of the car as per specification, which you told I want a red car. Okay. Now, when the car comes to you, means it definitely happens when you look at a picture and when you see the car in real, it is different. It can happen. Colors can deceive. So you ask for red color and then you got actually some variant of, or you can say you got wine color. Okay. So which is not something which you wanted. So it does not comply to the quality characteristic which you were looking for. So similarly, you can have n number of quality characteristics with respect to whether if it's a variable or an attribute. Now, why it is important to talk about variable and attribute over here is that uh, often the techniques which we are going to employ for variables, for the quality characteristics which are variables, they'll be different as compared to the ones for which we use uh, for which we use the attributes, means they can vary a lot, and that's why we need to know that what kind of quality characteristic are we talking about. Okay, now with respect to quality characteristic, there are some terms which we need to know, which is non-conformity and conformity. So let me take that. So there are terms like non-conformity, and then you have non-conforming unit. There are two different things. So non-conformity, can anyone tell what is the difference between the two terms, non-conformity and non-conforming unit? Can anyone tell? What is confirming? What do you mean by confirming?
Like validating something like a given.
Exactly. Validating. That is something you say that I want a 10 kg vegetables of certain type. Okay. You place an order and you get 9 kg, but you are charged for 10 kg. So it is actually a non-conforming order. Okay. You ordered for 10, you got 9. So that is non-conformity, a non-conforming item. Now, non-conformity and non-conforming unit, let's try to understand it like that. Defect. So defect is a term which is related with non-conformity. For example, in your mobile phone, you can have several type of defects. Like you can have a scratch is a defect. You can have problem with your speaker. That could be a problem. So that is a defect. You can have a problem with uh, audio, in the sense earphones, that could be a defect. So that is a non-conformity. We can say a quality characteristic that does not meet its stipulated specifications, or what has been claimed, it doesn't meet those. Okay. And then non-conforming unit is another thing. It's kind of an object. It is an object which can have multiple non-conformities, different type of non-conformities in it. So unit can have more than one non-conformities, multiple non-conformities, or single non-conformity can also make a non-conforming unit. For example, you say again mobile phone. So if it is having scratches, it is a non-conforming unit. Now there are multiple types of non-conformities or multiple type of defects which make a defective. So non-conforming unit is kind of a defective unit. Defective unit. So that's the difference between non-conformity and non-conformity, a non-conforming unit. And why are we talking about it? Is simply because the way we deal with non-conformity in quality control is very much different than how we deal with the non-conforming unit. Okay. Now, a quality attribute If a quality characteristic is an attribute, we can say it is either conforming or non-conforming. Okay, and then variable can be attribute, but attribute can now one question from you: can a variable be an attribute? Can a variable be an attribute? That is a quantity uh, which can be expressed as non-measurable. Can a variable be an attribute?
I think it can be like if we put a mark on it, let's say, like if for a mobile phone we say that it has 7 hours battery life. That is what is being said. But if it is having 6 hours battery life, then it will be a non-conformity. So like it would be either it can have the 7 hour or it cannot.
Yeah. So you are there. So let's say what Kavi is saying is 7 hours battery life. So you can also say that if does it comply to, does it match the battery life which it is claiming to have or not. So you can say yes or no also in that. What at one side you can measure it also, that how much time does it last, but at the same time you can convert it into yes and no also. Getting it? So a variable can be expressed in an attribute. And why would you do that? Can you tell why would we want to express variable as an attribute at times? Why would I want to
A
express?
non-conforming unit.
Yeah, why would I want to do that? Why would I want to express variable as an attribute? Yesterday, I've given example of some mobile units being quality checked. So it was taking a lot of time. It is related to something like that.
So that like maybe to create a bar of like if this is achieved, then we can say that it is a good product or good quality product.
Anyone else? Karvi, I think I just dropped the hint, or maybe I've already answered it. Anyone else would like to pitch in? Shubhangi, Neha, Shrija, Narendra. Anyone would like to tell why would I want to express variable as an attribute?
So
Okay.
we might not have the exact data sometimes.
Huh?
So we might not have the data, exact data to measure it
Yeah, I mean
sometimes.
you are close. See, actually, if you have to measure, it takes time. But if you just have to check whether it is complying or not complying, it is easier. Getting it? If you don't want details, you want to know whether it is complying or not complying, then you can save a lot of time. If you have to go in details of the measurements, it's going to take a lot of time. So that's why at times we would like to express variables and attributes only. Now another question: can attribute be a variable? Can attribute be expressed as a variable? I mean, the thing is that by nature it is an attribute. Can we express it as a variable? Can you think of any instance where something is there's an attribute and you want to you can express it as a variable? Yes, anyone? Yes and no. Whatever comes to your mind, say yes and say no in the chat box. Give your opinion in the chat box. Say yes if you think it can be expressed. Say no if you think that it cannot be expressed like that. Varun Sani says yes, it can be expressed. Attribute can be expressed as a variable. Karvi is saying yes. Now everyone will say yes, huh? Okay. So Varun and Karvi, you are the leaders. Can you tell why do you think that with an example you have to tell why can an attribute be expressed as a variable?
Sir, if we set a relative point like measuring it to a standard, then it can be converted into variable.
You have to give an example. It all becomes very hypothetical without example.
So, like, if you're talking about the comfort or ergonomics of a car or a flight, maybe,
Okay.
then in that case, what we can say is that, like, we can like give it a value by saying that we tested this on this many people, and out of them we surveyed, and out of them these many found it ergonomic or comfortable.
No, but then what are you measuring? What is the quality? Name that quality characteristic which is an attribute. You have to be specific over here.
Like, if we're talking about the comfort,
Okay, comfort is an attribute. Okay, so
yes.
by nature it is an attribute. Is there a unit to? Can you have a unit to comfort?
No.
You can't have a unit to comfort, right? So how can it be a variable then?
Like, if we but we can still like measure it in terms of what most of people find it, like if this is
That is subjective. See, that's the point I was coming to. Some people may say that I'll ask you, how did you like the coffee? And on a scale of 1 to 5, you give the rating. So I give rating 4. So you say it is a variable. Okay, you cannot see that is a linguistic scale. You cannot use the linguistic scale as a variable. Okay, because it is subjective. It changes from person to person, while an actual variable does not change. Are you getting it? A 10 centimeter line will be a 10 centimeter line only, irrespective of what scale you are using, irrespective of, I mean, if the scale is up to the standards and all. So a 10 centimeter line is going to be 10 centimeter line, but a same coffee can have 4, 5, 3, 2, 1 for all. So that is an attribute. I mean, that is there is subjectivity over there. It's an attribute. You can't have a single measurement for that. Or similarly comfort. So for now I'm saying attribute can't be expressed as a variable. Okay. If you have a counter argument, you can always come up with that. But for now, we can say that variable can be expressed as an attribute, but attribute can't be expressed as a variable. Okay. Until unless you find anything other than this is what the statement stands for. Okay. So we have learned about non-conformity, and corresponding to non-conformity, you use the term defect, and corresponding to non-conforming unit, you use the term defective unit. Okay. Then you have specifications. There are terms. There's a term like specification. What is the meaning of specification? Who gives the specification? Specification and standards. These are two different terms. Can anyone tell what's the difference between the two? Or is there a difference between the specification and standard?
Specification is basically what it is, and whereas standard is what it should be.
Yeah, somewhat right. Specification is something which is offered. Okay, it is generally used in procurement or production procedure, to define the procedure or process, that if let's say you are using a motor of 2 horsepower, so then corresponding to this, your the generator which is there should be of this much VA, kVA or VA, you can say that, volt ampere, to support that motor, right? So this is something which is this is a standard or a specification? Tell me that if I have to use this motor of let's say 2 horsepower, and when the light is off, when the light is not there directly, I have to use a generator to run the motor. Okay, so I have to give some specification of the generator in terms of volt ampere. Okay, so let it be x volt ampere. So is it a standard or a specification?
Specification.
Anyone else? So one thing that you can say is specifications are sort of requirements. Okay, and standard is something which is which defines the specifications. So it defines the requirement. Standards define the requirement. So here in this case, if we say a motor of 2 horsepower is to be run by a generator of XVA, so we are giving specification for a generator. While according to, and how do I establish this? How do I establish that how much is required? Through the use of standards. Okay, so which comes first? Standards comes first or specifications come first? It's like egg and hen. So which comes first? Standard. I mean, it may look like egg and hen, but it is not. So which comes first, standard or specification?
So standard.
Standard comes first, and on the basis of standard, we lay down the specifications. Okay. Okay. So now we talk about quality control. Okay. I'll be using Amitav Mitra, and there's another book is Besterfield. So 2 books I'll be using, and I'll share it with you. So right now I'll be using Amitav Mitra. So this is a very good book, or you can say it's a Bible of quality control. So I'll share it with you. Now, quality control is defined as a system that is used to maintain a desired level of quality in product or service. So, quality control is practiced to ensure desired level, desired level of quality in a product or service. In a product or service. So, how it can be achieved by planning, design, use of proper equipment and procedures, doing correct inspection. So, there are 3 main sub areas of quality control. 3 areas, 3 sub areas. The 3 sub areas of quality control are one is offline quality control. I'll write QC, statistical process control, and acceptance sampling plan. So offline quality control and statistical process control and acceptance sampling plans, these are the three main sub areas. And we will visit them one by one, but we'll be focusing more on the statistical process control because this is something which you can relate to easily and it is most widely used. So offline quality control, what is that? So offline quality control consists of procedures which deals with measures uh, to select, and we choose the processes and the parameters and their parameters such way that the deviation between the process process or the product output and the standards will be minimized. So we want to minimize the deviation between minimize deviation between output and the standards. So what do we do is we design offline quality control. So offline means that what is meaning of line over here? It's not like related with the internet, but it's actually related with something. There is a production department where the manufacturing goes on. It is in terms of manufacturing. So this is, you can say, production happening. Before production, you plan how the product will be produced, or the designing of the product happens over here. Designing before the production, designing happens. Okay, so it is related with something like design of products and processes so that it meets the so that the output will meet the standards. Are you getting it? So offline quality control is something like you design your product in such a way initially that it is going to meet the requirements. For example, you can say that you have to make a crane. This crane has to lift 20 tons of weight. Okay. Now the whole thing has to be designed, including crane hook, including the strength of the arm which on which the crane hook will be hanging. Okay, and the what and if there has to be, what will be the capacity of the engine which can actually lift and drag 20 tons of weight, right? So this is all offline quality control. That means without even producing, you are actually trying to make the whole thing, because it is going to tell. Offline quality control is going to help in designing the product so that it meets the specifications. The specification is that it has to lift the 20 tons of weight. So this is the specification. Are you getting what I'm saying? So without offline quality control happens before the production starts. And or for the simple, you can also take simple examples related to electronics. You have to make an amplifier which can amplify the wavelength by some percentage, right? So what should be the characteristics of that amplifier? I mean, how you're going to make that? So can you tell what are the important ingredients which is going to decide how much degree of amplification will happen? What are the ingredients in an amplifier which decide that? Yes, can you tell? Anyone? Can you tell? What are the ingredients in an amplifier which governs the amplification of a signal? You are all electronics people, right? So that's why I'm asking this question. I don't know the answer to this question. So you'll have to help me out here. Yeah? Anyone? So that means you don't know what is amplifier. Okay, tell me what's the difference between oscillator and amplifier?
Sir, oscillator में we generate signals, and in amplifier we amplify the waveform. In theoretical way, we can say that in amplifier the amplitude of the waveform the amplitude of waveform will greater in by using amplifier, and by oscillator we generate waveforms. So that
Okay,
is the difference.
okay. So what I was saying is that while you're designing amplifier or you're designing an oscillator, they have to cater to some demand, or someone's going to purchase that anyway. So they want कि ये इतना करना चाहिए, इसकी wavelength इतनी increase करना चाहिए, या अगर आप wave super impose कर रहे हैं दूसरी wave पे, oscillator से you generate the waves, right? And you superimpose on them to increase the detectability of the waves, right? So someone who's going to design that is actually a part of your offline quality control. Okay. Then we talk about statistical process control, SPC, the second one. Statistical process control, SPC. So statistical process control involves comparing the output of process and service with standard, and then taking a remedial action. For example, I take 30, it involves sampling, it involves a lot of statistics. So if I'm taking a sample of, let's say, 30 units, and I apply the techniques of statistical process control on that 30 samples. And because why am I doing sampling? Because I can't do 100% inspection. So I'm doing sampling over here. So I want to find out, is there any way, can I accept that, let's say these 30 samples are representing a lot of 500 items. So the thing is, can I accept all these 500 items and send it to customer? Okay, so that's the objective of statistical process control, where it involves comparing the output of a process. Output could be your quality characteristic, okay, it could be the dimension, it could be the conformance with the standard, and if it is not, and then we find out if all the 30 units are within the requirements or not. If they are within the requirements, then we say, okay, we can accept the lot and send it to the customer. If there is an issue, we find out a signal is raised that the process is out of control, okay, and then we say you have to check it again, and you have to find out why it is. So a lot of investigation goes. So a lot of detective work is there in statistical process control. We will do all that. So these are also called online control procedures. These are online control procedures, SPC. Online because it happens after the production has happened or while the production is happening. Okay. While offline means before the production is happening, you are doing all that. So this is your statistical process control. So we go further. So you must be thinking, if we have already ensured that offline quality control, and we have already ensured that the design is good and all, why there is a need for online quality control? Can anyone say that? Can anyone answer that? If I have already done offline quality control before the product is being made, why would I require online quality control? Yes, anyone? Yes, are you listening? I don't
Yes.
know.
Yes, sir.
Okay, so the question is, why SPC if we are already practicing offline quality control? Why we have to do statistical process control if we are already practicing offline quality control?
Like we don't know what might happen while it is being created, the product.
Okay. Anyone else? I mean, you are right in a way, but a bit vague. See, I'll give you an example. If I if I say that I want to produce, or if I ask you to hit a bullseye, I give you 100 darts, okay? And if I ask you to hit a point on a wall all the 100 times, can you do that? Or even can a robot do that? I mean, we are not talking about a digital world, we are talking about a real world, Newtonian world, where the new laws of Newton are playing. So 100 darts are there, okay? And there's a point on the wall, and I want to hit that point all the 100 times. And I've done all the practice and all, whatever, and I know all the rules of projectiles, and I know all the rules of darting. Will I be able to do that?
No.
No, sir.
No, sir.
Why? Why will I not be able to do that?
There will always be factors that have been unaccounted for, like wind or something else.
We say that these are the random variables. So there are random variables involved in I mean, there is a lot of randomness. The whole universe has a lot of randomness. You know entropy, right? What is the meaning of entropy? What is the implication of entropy in our life?
Sir, entropy is randomness.
Yeah. So it is natural that there is going to be randomness in the process. Always there is going to be some randomness which you can't account for. Okay, for example, I ask you strictly to enter exactly at 8 o'clock in the class. Otherwise, you will not be allowed to enter. Okay, will you be able to do that exactly at 8 o'clock?
No.
Or you put an alarm for yourself to get up at 6 o'clock in morning, and I'm sure in winters these days, every one of you must be snoozing it hard. Like God only knows that how much times you be snoozing. So let's say you plan it all and you like offline quality control you do for yourself. You plan and all everything. You make it as perfect as possible that you're going to wake up at 6 o'clock in morning, and you let's say you sleep at 6 o'clock in evening, so that you have a very good 12 hour sleep, and then suddenly at 6 o'clock you'll get up in the morning. Is it still possible to do that?
No, sir.
Yeah, none of you will be
No,
able to
sir.
do that. Maybe 1 or 2 days, but if you say in long term, or if you say in a steady state, you will never be able to achieve that target. Okay, so that's what the implication is. The entropy, the inherent nature, or it is natural to have randomness in the process. Now, because of this randomness in the process, even though you have done all the checks of the offline quality control, there are still chances that you may deviate from the target. and you have to keep a check on. So you have to be able to predict that variability. If you are able to predict that variability in the process, variability with respect to what? With respect to the quality characteristic, variability in the quality characteristic. For example, I'm uh, I'm all of you have done workshop practice, right? Have you done workshop practice course? Yes, guys.
No, no.
Okay, it was not there in your curriculum. Okay, so let's say you are making a metal object, and on a machine you are making it. We call it as a lathe machine. Okay, so you want to make a 5 centimeter diameter object. You just can't keep on making it all the time 5 centimeter, because it's going to be changing because of the entropy existing in the nature. Okay, so that is inevitable. You just can't produce a product conforming exactly to the same dimension, same quality all the time. Like resistance, you say, an electrical element resistance is 10 ohms. So is it exactly going to be 10 ohms? If you are producing 10 ohm resistors, will it be exactly 10 ohm resistor all the time?
No, sir.
No.
Will not.
No, sir.
Even though you are having the best of the processes in the world, you will never be able to do that. So in order to keep a check on that variability, in order to understand and predict that variability, we do statistical process control. So generally, what it is advised is offline is anyway you have to do that, because you have to design the product, and after that you have to do online quality control, which is very important. And we are going to spend a lot of time on statistical process control, where there you are going to have the component of data analytics. Then we have acceptance sampling plans. So acceptance sampling plans, they deal with the inspection of product or service. Okay, that means after it has been produced. So now acceptance sampling plans are generally used when 100% inspection is not possible. So we can write 100% inspection not possible. So it require generally what we do is we require take a decision on how many items should a sample contain. Like production is going on continuously, and we have to find out how many items should we pick. So you must have seen in the vegetable market, no? You go. So let's say you are purchasing beans. Okay, how do you purchase beans? I don't know how many of you have done that, but beans, the objects which are smaller or grain. How do you do that? Yes, Rajkumar Parikh, are you there?
Yes, yes, sir.
Have you
Uh,
have you purchased grains or dale ya uh, beans from the market? How do you
yes, sir.
purchase that? Do you pick every single one of that, or like ladyfinger?
Yeah, when it comes to vegetable, I may decide to take out from my end only. But when it comes to like grains and all these things, I might believe on the that uh, that only that provide me the best quality or the product quality,
No, let's say you have to
like the brand.
even if you know whether the quality is good or not. You let's say you are an expert in that. So are you going to pick every bean? Let's say you have to purchase 2 kg beans.
No, no, no. I guess
How do you purchase them? You are a quality expert. I mean, you know the best how to purchase a vegetable. Let's assume that. So how
uh,
do you do that?
In vegetable case, I guess I will be prefer to take out by my hand only.
No, by your end, I'm saying that you have to purchase 2 kg. So how do you purchase 2 kg?
Yeah, I pick up the fresh one.
So in 2 kg, can you say how many? I think 200 to कितनी होती होंगी? Any other person can in 2 kg how many beans will be there? Anyone?
300 approx.
In number, in quantity, I mean not in I mean if you have to discretely count them, how many would be there? Just make a wild guess.
Approx 300.
300 to 350 may be there. Okay, so are you going to pick each and every bean? 350
No,
beans?
sir. No,
No,
sir.
sir.
We will take in whole of the quantity,
So how do
and
you
if we
decide
find
whether you
something
have to take it or not? How do you decide whether you have to take it or not? Is it just because you just have to take it, you are going to close your eyes and take it? Or are you going to take some and check?
we will see if there are more of adulterated one, then we will not take it.
So you can't check all the beans, right? You are going to pick a few of them and then check it, right? It's whether the quality looks good or not. Or the wheat that you purchase, maybe some of you might be purchasing
Just
the
to
whole wheat.
sample a bit of it, like in our hand, and then see.
Yeah, so same thing happens over here in acceptance sampling. You can't do when you can't do 100% inspection, just like the example which I've given you for the grains or for the other things. Then you have to depend on sample. So you pick a sample and you inspect it, and then we do some process in that. We set a criteria, acceptance criteria. If it meets the acceptance criteria, we select the uh, whole produce, or we reject the whole produce based on some sample. So acceptance sampling plan is that kind of process. Okay, so we conclude for today, and then we are going to continue from here on in the next class. Okay, so any doubts in this today? You give your attendance, all of you. You have the link already, right?
Yes, sir. Thank you, sir.
Okay, so I'll stop my presentation now. I'll stop the recording here.